Okay, this is your well-rounded math teacher, Mr. Picard. We're going to talk about factoring today, and the reason we're getting into factoring is this. We are working with quadratics, and we will be getting into polynomials, and we need to know how to factor in order to find solutions and zeros to quadratics and polynomials. So just big little couple days of review with factoring for you guys. You guys have done this before. We just got to get familiar with it again. So what is factoring? Factoring is the act of taking apart a number or an expression and writing it as a product of its factors. So when you look at this one right here, 20, if you were going to factor it, you'd find out, well, 4 times 20, or 4 times 5 is 20, but you can break up 4 into 2 times 2. These are all considered factors right here. 2 times 2 times 2 is 20. The two 2's and the 5 are your factors, what you're multiplying together to get 20. 15 a squared b cubed, what would you multiply to get 15a squared b cubed? Well, 5 times 3 right here is 15. A times a is the a squared, and then b times b times b is your b cubed, but all of these together are your factors. This one actually has 1, 2, 3, 4, 5, 6, 7 base factors for 15a squared b cubed. So that's what factors are. Whenever you multiply two things together, the things you're multiplying together are your factors. A couple of factoring puzzles here. Basically, we're going to break this up and just practice using or finding factors. Actually, if you look at first of all the 12 and the 8 here, what goes into 12 and 8? And of course it's 2, but you want the greatest common factor. 4 goes into both 12 and 8. What about 12 and 15 now? 3 goes into both of them, and you can see that 3 times 4 is equal to your 12 in the middle here. Well, 4 times what will give you your 8, and that's 2. So 3 and 2 are a couple of factors that go into both of these right here. And then finally, 3 goes into 15 over here 5 times. So 3 times 4 is 12, and then 3 times 5 is 15. Basically, we're looking for this box right here, and that's going to be the 5 times the 2, and that's 10. So working with this box, we're just trying to find factors, and then finally find that missing square. We don't need these. Just put them on the sides. Try another one here. 15 and 18. Well, that's definitely going to be 3. And 15 is 3 times 5. So I got those two. 18, 3 goes in there 6 times. 15 times what will give me 35? And that is 7 right here. So this last box is going to be the 7 times the 6, which is 42. So forgetting this again, we're looking for our factors, and if you find all the factors correctly, you'll be able to find that last box. And I will let you guys do these two. It'll be good practice working with factors for you. Exploring factors a little bit, we're going to work backwards here. 5 times 10, these are what we call factors. And when you multiply 5 times 10, you get 50. This is your product. So basically what we're trying to do when we're factoring something is take a product and pull it apart. So we're going to be getting into problems like this where when we factor something, this is what our factors look like right here. So just looking at where they come from, first of all, let's finding a product or simplifying something is the opposite of factoring. So just kind of working backwards here a little bit, actually working forwards. Factoring is the working backwards part. If I was going to simplify this, I would use the distributive property. 5x squared, first of all, times the 3x is 15x cubed. And 5x squared times 2 is plus 10x squared. Now, this is what you're basically looking at. You're pulling out something out of these two terms that they have in common. They're both divisible by 5. This is the 5 right there. They both have an x, and you can pull out of these two terms smallest x power to both of them. So if I have an x cubed and x squared, the most I can take out is a x squared, and that's what we have right here. 5x squared is our GCF, greatest common factor of these two terms. So what you guys have been doing is simplifying quite a bit. Whether it's foiling or GCF, we're going to be going backwards and factoring today and, well, quite a while. Find the area of a rectangle. There's my rectangle. With a length of 5 and a width of 8. Well, there's 8 and there's 5. And how do you find area? Well, 8 times 5, and that's equal to 40. So once again, here's my product, and these are my factors. Well, what we're going to be getting into, though, is working with more expressions rather than just numbers. Find the area of a rectangle with length 2x squared and width 3x. So we got 3x times 2x squared. Once again, these are my factors right here. These are what we want to be able to pull apart eventually. And this is equal to what? 6x cubed. Now this is only one term. You generally don't factor one term, but we're just looking at factors and where they're coming from. Here's the big one. This is the one we're going to do a lot of. This is two binomials. And when I want to multiply two binomials, I use FOIL. First, outside, inside, last. Those are the three products. You can see them listed right here. Okay, so first of all, first terms, x times x is x squared. Outside, x is on the outside here, and 2 is on the outside here, so that is going to give me 2x. Inside, right here, these two terms are on the inside, 3 times x is 3x, and finally, the last term in each one is 3 times 2, that's 6. And this is going to give me a grand total of x squared plus 5x plus 6. This is my answer right here if I was multiplying them. Now, what we want to do is take something that's simplified like this and work backwards and come up with the two factors right here in order to solve them eventually. And, well, you know what the answer is going to be, but I'm going to show you how you kind of set it up. First of all, x times x is x squared, so that's what goes in the first two right here. What goes in here and here next kind of depends on the 6 and the 5. What you do is this. Little cue or key here we use is what are factors of 6? In other words, what would you multiply by to get 6? But you would add together and get 5. Well, 1 and 6. 1 times 6 is 6, but 1 plus 6 is not going to be 5, it's 7. But 2 times 3 is 6. And then 2 plus 3 is going to give me my 5 right here. So those would be the 2 and the 3 that we put inside here, and they're both positive. And you can see that's what we started out with over here. So factoring what we call general trinomials is this type of a problem right here. Factoring is simply the opposite of foiling. It's the opposite of simplifying or multiplying, if you will. When factoring, answers will look similar to the original problems above, the problems that we just did. GCF, this is greatest common factor. In other words, what can you take out of all the terms in your expression? General trinomials, we just broke one of those up. This is where you're going to take factors of C, your constant. C is your constant right here. So what would you multiply to get C? But you would add to get B. And once you do that, and basically, you know, x squared here is just going to be x and x. What you're looking for in this little puzzle is what you're adding or subtracting from the two x's. And then this one, general trinomials, and I'll probably show you this later on tomorrow. So General trinomials with some number in front of it. Okay, the first one, GCF, greatest common factor. Well, let's look at all four of them. When I look at 12x and 36, these two terms here, what do they have in common? Well, 2, but there's bigger numbers. I think they both have a common factor of 12. Then you're going to put a set of parentheses here, and we have two terms, so there's going to be two terms inside here. In other words, what I multiply by 12 to get the 12x? Well, that's easy. It's an x. And what do I multiply by 12 to get the negative 36? That's negative 3. Another way to do it is divide every term by 12, because that's basically what you're pulling out. 12 divided by 12 is 1x, and then 36 divided by 12 is 3. So you can do whatever you want. Looking at these two terms, 8x squared and 16x. Yeah, 2 goes into them, and also 4, but you want greatest common factor, so I'm going to take an 8 out. They both have an x term. I don't take it on x squared here. I can take out an x to first. Basically, the rule is this: if they have the same variable in all the terms, you take out the one with the smallest power, and that would be x to the first over here, or just x. So 8x is my greatest common factor. Two terms inside here. Okay, 8x times what will give me 8x squared? Well, I need another x. And 8x times what will give me 16x here? I need a 2. Also, you could divide them by 8x if you wanted to, and that would give you the x and the 2. And this is factored. How many factors is that? Some people might say 3, but really it's 2. 8x is your first factor, and everything in parentheses makes up another factor. So there are two factors here, just like there are 2 factors here also. We're going to try number 10, and I'll let you guys try number 9 then. First of all, looking at the 5, the 20, and the 40, well, that should be pretty easy. It's 5. X to the 7th, x cubed, x squared. They all have an x. Take out the smallest power, x squared. So 5x squared is my greatest common factor. Now I'm going to have 3 terms inside here, because I'm starting out with 3 terms. Well, I don't need to multiply by 5 to get the 5. I already got that, so it's 1. But I do need some x's, and I need it. Oh, wait a minute now. Put next to the 5th there, that's supposed to be x squared. Sorry about that. But I do need an x to the 5th now. X to the 5th times x squared is going to give me x to the 7th. 5 times negative 4 is going to give me the negative 20 here. And I have x squared. I need an x cubed, so I need one more x. X to the 1st. I already have an x squared here, so I don't need any more x's, but I do need an 8. And we're done. Now you should be able to distribute through this. And when you distribute through this, you should get the exact same expression that you started out with. If you don't, then you made a mistake somewhere. You guys can try number 9. General trinomials, x squared plus bx plus c. Find 2 numbers that give you a product of c and a sum of b. Okay, here we go. This is a general trinomial, 3 terms. It's of the form x squared, it's got some bx, and it's got some constant. So we're going to set up a set of binomials that we're multiplying. They're factors. Whenever you find factors, you're multiplying them. And it's really simple to get x squared. That's x and x. But now what we do is, here's my c. We want to find factors of 8. In other words, what would you multiply to get 8? But then right here, the number in the middle, the b, or the number in front of x, what would you add to get 6? Now, factors of 8 are 1 and 8. That's not going to work. But 2 and 4. 2 times 4 will give me the 8, and 2 plus 4 will give me the 6. So I'm going to put a 2 here and a 4 here, and they're both positive, so it's x plus 2 and x plus 4. And there are my factors. It is factored completely. How many factors do I have? Once again, 2. Each binomial is a factor. So, same thing here. It's got an x squared, an x term, and a constant, so it's a general trinomial. X and X. X times X would give me the X squared. Now, what would you multiply to get 12, but add to get 13? Multiply to get 12, but add to get 13. Well, 3 and 4 isn't going to work. 1 and 12 isn't going to, well, yeah, 1 and 12 will work. 1 times 12 is 12, and 1 plus 12 is 13. Once again, they're both positive here, so it's plus 12 plus 1, and we're done. Those are my two factors. I'll let you guys try number 13, and we will finish this up tomorrow. Have a great day, and we will talk to you later. Shout out to all those deer hunters out there. Good luck.